Hello friends, my name is Chetan Naithani and today I am going to start this new series about database normalization. In this series we learn about what database normalization is and why do we need database normalization. Basically we'll understand what are the disadvantages of the normalized database and so that in a way we will understand that why do we need database normalization. And in the subsequent part of these videos, like part second and part third, we'll understand about first normal form, second normal form, third normal form, fourth normal form, and so on, right? So let's get started. So just coming into a basic definition of database normalization. A database normalization is a process of organizing column attributes and tables of relational database to reduce data redundancy and improve data integrity, right? So it's a simple definition. I've taken it from wiki, and so let's try to understand what this definition is trying to say about database normalization. So first of all, it is saying that this is talking about data redundancy. So what data redundancy is? Data redundancy is simply duplicacy of data, right? So denormalized database will be having a duplicate values, duplicate records, and duplicate column record, duplicate row records also, right? And then it's talk about improving data integrity. So through database normalization, we are improving data integrity also, right? So we are making database more manageable, right? And so what database normalization is, what this definition says is simply is a process of organizing column and table. So database normalization is simply what simply database normalization is. It is simply organizing column and tables and the relation between tables into a specific way, so that we can reduce redundancy and we can improve data integrity of our database, right? Okay, so let's move forward. So here we have a simple database. This is totally denormalized database, right? And in this database we have some column. This database actually is representing employee table. That is, it is representing a set of employee records, and it has a few columns. It has employee ID, right? It has employee name, and employee name, as you can see, is a full name. It's not first name, middle name, and last name. Then we have employee age, then we have employee department, and here the business rule is like department can employee can have multiple department. Employee can belong to multiple department. So a department will have manager also. Since employee can have multiple departments, so like employee can have multiple managers also, because manager is dependent upon department. And employee has some address values. Employee has some zip, uh, postal code, and then city, and then state. So here you can see that city and state are totally dependent on zip code, postal code, and employee is assigned a postal code which is enough to uh, represent the address of an employee, right? Okay, so let's try to understand what are the disadvantages of this totally denormalized database, right? So here first disadvantage we can see is there is lot of data redundancy. So there is lot of data duplicacy. So here you can see that the city and state column, I mean, are repeated unnecessarily, right? We need to have zip column here, postal code column here, because we need to have address information of employee. But city and state can be stored in another table, so we could have reduced this city, reduce the data duplicacy, data redundancy, right? So we could have saved some space here, save some memory here, and we could have reduced the size of our rows, which could have improved performance, right? So this is first thing. Then this denormalized database is either non-searchable or is either it is very difficult to search this database. For example, take example of name column. For example, I asked you to create a query for searching employee name as Paul, right? Having name first name as Paul. So a simple query will be select star from employee. Employee is a table name where name is like Paul, right? Paul percentage, right? So you can simply write that query. But suppose say if prefix is also there, suppose Mr. or Doctor or any other prefix will be there, then this query will be more difficult to manage, right? So you can see that column name of a totally denormalized database are either non-searchable or either very difficult to search. So this is second disadvantage of this denormalized database. Then we have this insert, update and delete anomalies, right? So if I need to insert an employee with department infotech, right? So you can see here we already have. So you can see here we already have two department which are meant to be same, right? We have a department as IT here, IT, and we have another department name as information technologies. However, they are intended to be a same record, right? But as there is no constraint, so different name are entered here. So one department is recorded with two names, right? So now suppose there is no constraint and I make a mistake and I may insert another record with info tech, right? So I create another department. However, I don't intend to create another department. I only intend to insert an employee record having a department as information technology. But since that database is not normalized, so I'm having an insert anomaly here, right? Similarly, if I update this third record as Venkat with a department infotech, same INFO tech, then I non-intentionally create another department, right? However, I don't intend to create another department. I only intend to update the department of uh, third employee number 3 into the already existing information technology department. But since there is no constraint, I am creating another department. This is update anomaly, right? And third one is, if suppose third one is delete anomaly, right? So sorry, I realized I just had a slide which is not for insert, update and delete anomalies. So here is the slide. So I mean, we were explaining about that insert, update and delete anomalies. So like I explained the insert anomaly, I explained the update anomalies, and similar way, if I delete that employee number 3, that delete, if I delete that employee number 3, uh, even I don't intend to delete that account department, I only intend to delete employee number 3. So even then I'm deleting that account department. So that is delete anomaly. So here you can see in a non-normalized database, in a denormalized database, we can have this insert, update, and delete anomalies, right? And here we are into the fourth disadvantage, that is data inconsistency and integrity issues. So here you can see these two columns, right? These two columns. Here you can see, since there are no constraint, the same department is entered with two different names, right? So data is not consistent here, right? So this is another disadvantage. And now we are coming to some bigger issues, some major issues, which are result of all the issues we discussed up to now, right? So due to all these things, the evaluation of our application for which we are creating this database, for which we are maintaining this database, is very difficult, right? For example, if I have to create a UI which updates a department, I need to update all the tables. For example, employee table, right? Even if I am not intending to touch the employee table, I have to, because the department name is spread over all my database tables. I mean most of my database tables, right? So if this task is even more difficult if my data is not consistent. For example, this IT department have two different names. So if I have to update name of information technology department, I have to update these names. So it is very difficult task, right? And to do all the things, I have to write additional code, right? To compensate this schema disadvantage, I have to write additional code. I have to write the code to update employee with the code to update department table, right? So I mean this all things, because I have to write additional code, I have to manage additional things, unnecessary things. This result in performance degradation, right? So these are the basic disadvantages of a denormalized database. And in next video we'll look into first NF, and in subsequent videos we will look into 2NF, 3NF database normal forms, which is basically the steps to normalize the database, so that we can design an application which can evolve very easily, and which is very easy to manage, and which gives good performance also, right? So for that purpose we'll learn how to change our database, denormalize database into first normal form, second normal form, and third normal form, and then fourth and BCNF also, right? So that's all for this video, and if you like this video, please subscribe to our channel. This will be a great motivation for us, and thanks for watching. Bye.